At the core of an electric car is its battery, which stores the electrical energy needed to power the vehicle. These batteries are typically made of lithium-ion cells, similar to those found in a laptop or smartphone, but on a much larger scale. The energy stored in an electric car's batteries allows the car to move, and they can be recharged by plugging the car into an electrical outlet or a dedicated charging station. The electric motor is the powerhouse of an electric car. Electric motors are simpler than traditional internal combustion engines. EVs therefore require less maintenance and provide a quieter ride. The car's motor helps it to move forward by turning electricity into mechanical energy. The entire process is highly efficient and allows electric cars to achieve impressive acceleration and performance. A useful feature of electric cars is regenerative braking. When a driver applies the brakes, the electric motor runs in reverse, acting as a generator to convert some of the kinetic energy back into electrical energy, which is then stored in the battery. This not only helps to extend the range of the vehicle but also reduces wear on the braking system, making the feature invaluable for efficiency and maintenance. How electric cars work. Electric cars, or electric vehicles, EVs, are vehicles powered entirely or partially by electricity instead of gasoline or diesel. Unlike conventional cars that use internal combustion engines, EVs rely on electric motors and battery systems to drive the wheels. This fundamental difference changes how the car operates, affects its environmental impact, and influences efficiency and maintenance requirements. Electric cars have become increasingly popular due to their ability to reduce greenhouse gas emissions and lower operating costs. Main components of an electric car. At the heart of every electric car is the battery pack, which stores electrical energy and supplies it to the motor. Most modern EVs use lithium-ion batteries, similar to those found in smartphones and laptops but far larger. The capacity of the battery, measured in kilowatt-hour, determines how far the car can travel on a single charge. A larger battery capacity allows for longer trips without the need for recharging. The electric motor is another key component. It converts electrical energy from the battery into mechanical energy, which turns the wheels. Unlike gasoline engines, electric motors provide instant torque, enabling smooth and rapid acceleration from a standstill. Electric motors are also highly efficient, often converting over 90% of the stored energy into movement, whereas conventional engines typically operate at only 20 to 30% efficiency. The inverter plays a critical role in controlling the motor. It converts the direct current, DC, from the battery into alternating current, AC, for the motor in most EVs, allowing precise control of motor speed and torque. The charging port and onboard charger allow the car to be recharged from an external power source. The onboard charger converts electricity from the grid into the proper form to charge the battery. Charging speeds vary depending on whether the car is connected to a standard household outlet, a faster level 2 charger, or a DC fast charging station. Electric cars often include a regenerative braking system. This system recovers some of the vehicle's kinetic energy during braking and converts it back into electricity to recharge the battery. Regenerative braking increases overall efficiency and helps extend the driving range of the vehicle. How electric cars operate. Electric cars operate in a relatively simple manner compared to traditional vehicles. When the driver presses the accelerator, the car's computer signals the inverter to draw electricity from the battery and send it to the motor. The motor then rotates, driving the wheels and propelling the car forward. Because electric motors deliver torque instantly, acceleration is smooth and responsive. Most electric cars use a single-speed transmission, eliminating the need for multiple gears. This simplicity reduces mechanical complexity and lowers maintenance requirements. Unlike gasoline-powered cars, EVs do not need oil changes, spark plugs, timing belts, or fuel filters, which significantly reduces long-term upkeep. Advantages of electric cars. Electric cars provide significant environmental benefits because they produce zero tailpipe emissions. When charged using renewable energy sources such as solar or wind, their carbon footprint is extremely low. In addition, electricity is generally cheaper than gasoline, and electric cars have fewer moving parts, resulting in lower operating and maintenance costs over time. EVs also offer a quieter and smoother driving experience due to the near-silent operation of the electric motor and instant torque, which eliminates the lag often experienced with internal combustion engines. Challenges and limitations. Despite their many advantages, electric cars face certain challenges. Battery range remains a concern for some drivers, especially on long trips, although advancements in battery technology are improving this aspect rapidly. Charging infrastructure, while growing, is still not as widespread as gas stations, which can limit convenience. Batteries are also expensive, and over time, their storage capacity decreases, although modern EV batteries are designed to maintain a significant portion of their capacity for many years. Electric vehicles are expected to become increasingly common as technology advances. Improvements in battery performance, faster charging solutions, and innovations such as solid-state batteries and wireless charging are likely to make EVs more convenient and practical. Government incentives, stricter emissions regulations, and growing consumer demand are accelerating the shift toward electric mobility. Eventually, electric cars may replace gasoline-powered vehicles as the dominant form of transportation. The future of the automobile is entering an era of transformation that may be as significant as the original invention of the car. For over a century, automobiles have been central to human mobility, influencing the development of cities, economies, and cultures. Cars have long been symbols of freedom, independence, and progress, shaping lifestyles and societal expectations around transportation. However, in the 21st century, a convergence of technological innovation, environmental imperatives, and changing social behavior is reshaping the very concept of the automobile. The traditional internal combustion engine, once the dominant force in transportation, is gradually being replaced by more sustainable, intelligent, and connected alternatives. This transition is not just about vehicles themselves, but also about the way people move, interact with technology, and relate to the environment. One of the most significant changes in the automotive landscape is the rapid rise of electric vehicles. Electric cars operate using battery-stored electricity, eliminating the need for gasoline or diesel and dramatically reducing carbon emissions. Advances in battery technology, including lithium-ion and solid-state batteries, have greatly improved vehicle range, charging speed, and overall efficiency. These developments are making electric vehicles more practical, affordable, and appealing to a wider population. Many leading automobile manufacturers have announced plans to phase out internal combustion engines within the next 2 decades, signaling a decisive shift toward fully electric lineups. Governments worldwide are supporting this transition through subsidies for electric car buyers, investments in charging infrastructure, and strict emission regulations. As a result, electric vehicles are not only becoming environmentally essential but are also increasingly integrated into everyday life, promising a future where transportation contributes less to air pollution and climate change. In parallel with electrification, autonomous driving technology is revolutionizing the way vehicles are designed and operated. Self-driving cars use a combination of sensors, cameras, radar, and artificial intelligence to navigate roads without human intervention. While fully autonomous vehicles are not yet widely available, semi-autonomous features such as adaptive cruise control, lane keeping assistance, and automated parking are becoming commonplace. The implications of autonomous vehicles are profound. By reducing human error, which accounts for the majority of traffic accidents, self-driving technology has the potential to save thousands of lives each year. Beyond safety, autonomous vehicles could transform urban planning. Fewer privately owned cars on the roads, combined with widespread ride-sharing services, would reduce the need for extensive parking infrastructure, freeing up space for parks, pedestrian zones, and other urban improvements. Cities could become more livable and less dominated by the presence of vehicles. Another key aspect of the automobile's future is connectivity. Modern vehicles are increasingly integrated into digital networks, communicating with other vehicles, infrastructure, and even personal devices. This networked approach, known as vehicle-to-everything communication, enables cars to receive real-time traffic updates, optimize routes, and respond to changing conditions more efficiently. Connected vehicles also offer new opportunities for convenience and personalization, transforming cars into mobile extensions of our digital lives. Passengers may work, stream entertainment, or engage in immersive experiences while traveling, effectively turning travel time into productive or enjoyable time. Additionally, connectivity enhances energy efficiency, as intelligent navigation systems reduce congestion and minimize unnecessary fuel or battery consumption. The social and cultural dimensions of car ownership are also evolving. Younger generations, especially in urban areas, increasingly prioritize access to transportation over ownership. Ride-sharing platforms, public transit, and micromobility solutions like electric scooters and bicycles are reshaping expectations of mobility. This shift challenges traditional automotive business models and encourages the emergence of mobility-as-a-service platforms, where transportation is a flexible, on-demand service rather than a personal commodity. Such changes could foster a more sustainable and equitable transportation system, reducing congestion, emissions, and the environmental footprint of individual travel. Environmental considerations are at the heart of the automotive transformation. Climate change, urban air quality concerns, and resource scarcity are driving innovation in vehicle design and production. Automakers are exploring not only electric drivetrains but also renewable and recyclable materials, lightweight composites, and circular manufacturing processes that minimize waste. Hydrogen fuel cell vehicles are emerging as another zero-emission solution, particularly suited for long-haul trucking and heavy-duty transport due to their rapid refueling capabilities and extended range. Advances in aerodynamics, battery efficiency, and vehicle architecture further contribute to reducing energy consumption and environmental impact. The convergence of these innovations demonstrates the automotive industry's commitment to sustainability, signaling a shift from vehicles as mere machines to vehicles as environmentally responsible tools for mobility. The future of the automobile also promises profound economic and societal impacts. As electric and autonomous vehicles become more prevalent, industries related to fuel production, car maintenance, and urban logistics will need to adapt. Jobs in traditional automotive sectors may decline, while opportunities in technology, software development, battery production, and charging infrastructure will expand. Cities, too, will transform as traffic patterns, parking needs, and public spaces evolve in response to changing transportation technologies. The car of the future will not simply transport people from one location to another, it will integrate with urban ecosystems, energy networks, and digital infrastructures to create a more efficient and harmonious mobility experience. In conclusion, the future of the automobile is defined by electrification, autonomy, connectivity, and sustainability. Vehicles are becoming intelligent, environmentally conscious, and deeply integrated into the digital and social fabric of everyday life. The shift away from traditional ownership, combined with advances in electric propulsion, self-driving technology, and connected mobility, points toward a future where transportation is safer, cleaner, and more efficient than ever before. Beyond practicality, cars will serve as extensions of human life, enabling new forms of work, entertainment, and social interaction. The automobile of tomorrow is not just a means of reaching a destination, it is a tool that transforms the journey itself, harmonizing human convenience with environmental responsibility. As technology continues to advance and societies adapt, the car will remain central to human mobility, but in ways that reflect the priorities of a more connected, sustainable, and intelligent world. Thank you for watching this video.